Hi, my name's Gwen Sexton. I'd like to welcome you to the second presentation in the series of presentations about LoRa and its use in an IoT environment. You can find the first presentation, which is a very high-level presentation, using the link at the bottom of this screen. And this presentation is going to a little bit more detail, particularly about the use and implementation of Node-RED. But just bear in mind the sorts of technologies that we're going to be using are LoRa and Node-RED, obviously, MQTT, and some Libelium WASP mode technology too. So let's just remind ourselves of what the physical components are in the system that I'm going to show you something about. So the first part is the Raspberry Pi, which is hosting an MQTT server and Node-RED itself. And connected to that through one of the USB interfaces, we have a Libelium LoRa gateway, so that plugs directly in. Transmitting the LoRa information is also WASP mode with a LoRa module plugged into that. And on top of the WASP mode board, we have a sensor board, and we're reading the information from our sensors and pushing that across the LoRa link itself. So the first part that we're going to look at today is really about publishing data to the MQTT broker. So in this particular case, in the environment that I have set up, I have the MQTT broker and the publishing client actually all sitting on the Raspberry Pi. But of course that doesn't have to be the case, and very commonly the MQTT broker and the publisher would not be on the same physical device. So we're going to look at that part first, and look at the Node-RED implementation of that, and then following that we're going to have a look to see how we actually subscribe to that data that's stored in the MQTT broker, and how that is displayed. So this is showing the Node-RED configuration. This is just a screen capture from the Node-RED environment, and immediately, if you're not familiar with Node-RED at all, you can see we have a very graphical environment, all working on a concept of flows, in this case running from left to right. And I would just add, of course, there are 1,000 ways to skin a cat, and this is just one way to make the whole system work. And I'm sure it may not be the best way, but it does actually work anyway. We've also got some debugging work going on in here as well, so this wouldn't be probably a final system. So we have things like the message payload there, which I'm outlining, and really these are debug statements which allow us to take a look at the output of the LoRa gateway directly here, and for this one down here, allows us to look at what we get when we've cleaned the data and presented it in an appropriate manner. Right, if you just bear with me for a couple of seconds, I'm just going to clear these little bits of scribble off the screen before we move on. Okay, there we are. So let's take a look at how we might configure the LoRa gateway module. Now really this is just a Node-RED serial interface module, and this is kind of what it looks like when we configure. The first thing that we need to do is just to select the appropriate serial interface that's available to us. And this takes a little fiddling, depends on the environment that you've got, but this is the serial interface that's on the Raspberry Pi module. And then we just need to set up the appropriate serial protocol values for baud rate, data rate, parity, and stop bits. And in this particular case, this is very much specified by the LoRa gateway itself. Now, there are other configurations that are available to us on this particular node, but the default values are perfectly okay. And one of the other factors, perhaps buried in the detail, is how we transmit the data from the physical LoRa gateway to our serial interface, and it's transmitted as ASCII strings. It doesn't have to be. We can reconfigure that if we want, and we can configure that as a binary delivery. But we have ASCII strings. The obvious advantage of ASCII strings, it makes the data much more readable itself. So once again, I'm just going to delete these little bits of annotation. Let's take a look at the next step in what we have to look at. So let's take a look at the data that's being delivered. So this data that we're seeing on the screen here is the data that's printed out by the debug statement that is up here. If I can get the pen to write. Yeah, so that's the data delivered from that debug statement up here, and you can see it's an ASCII string. It's composed of several components. Perhaps the first part of the statement, which I'm now underlining, is essentially header information. It's mainly metadata about the remaining data, but it does include node IDs, LoRa node IDs, and so forth, and start statements. The actual data that we're transmitting from the sensors, we can see this if you read into this carefully. You can see we've got a statement BAT:100 followed by a hash. So the BAT is the battery value, colon is a separator, and 100 is telling me that the battery is 100% charged, and hash is just a separator statement, or separator character between the differing sensor outputs. And the next one is temperature, then the next one is humidity, next one is pressure, and the final one is carbon dioxide output. So that gives you an idea of what the data actually looks like when we're pushing it out of the serial interface from the LoRa gateway. Okay, let's look at the next bit. So I'm now having a look inside the function block, which is, I'll just outline it there. So that's the function block there. So we're doing some processing on that function block. Now, the little bit of code here is just a bit of JavaScript code, is in development, and there's a few bits and pieces in there that are just helpful for me to debug what I'm doing, and helpful for me for a little bit of future development. The first element in there is just showing that some metadata in that data that we've passed across tells me how many sensors are being responded to, and I'm extracting that metadata with this line at the top of the code. And the second line, for those who aren't familiar with JavaScript, I'm just able to output that value to the console on the Raspberry Pi display, just for debugging purposes. The next statement that's a value is this one here, which is about splitting the ASCII payload into smaller chunks to allow us to get at the data that we want to really get at. So the data is packaged together, and the hash key is used to separate off the actual data into different sensors, and once we've done that, then we've got a little bit of a complex for statement, which is about going through that separated data and separating it once again using the split statement that you can see there into another slightly simpler array, so we can really get down to the numeric data that we're interested in. And once again, we're just looking at the output to debug. And finally, we're generating in effect a return value from this function. The way in which Node-RED works, it relies on passing messages into and out from each of the blocks in the diagram, and it uses a particular object format. The object format's moderately complicated, but one of the elements in there is something called payload. So we're setting the payload of a new message that's going to be returned to that cleaned sensor list. So we're returning that value. Another aspect of Node-RED, particularly when we're publishing, is setting the topic that we're going to publish to. Node-RED uses this concept of a topic to classify the type of data that has been stored in the MQTT server, and subsequently those units that subscribe to topics can get a hold of the data that's been published to those topics. There are two ways at least to publish data to topics, and one of the ways is that you can dynamically define the topic value in the message that's been sent to the actual broker itself. And in this case, we've just defined the topic to be sensors in this line. So there's a little bit more debugging work following that, which is all commented out, and the final line just returns the new message object to the next block in the statement. Okay, so let's just remove these scribbles off the screen, and we'll move on to the next line. Okay, so we're now having a look at the MQTT connector, and it's again a pretty simple scenario. We have to say something about the MQTT server, that is where it is. As it happens, it's actually sitting on the Raspberry Pi that this Node-RED is running on, so its IP address is localhost rather than another IP address. There's a specific port number that by default the MQTT servers are set up on. It's 1883, so we've got to direct the data at that. In this particular case, topic is blank here. I haven't put anything in topic because I've specified it in the message and I don't need to. There are a few other parameters that I'm not going to talk about today, but you can put quality of service in if you wish. You can name the block, which I perhaps should have, and you can say something about how long the data is retained for. And that's just about it for this particular section. So I'm just going to remove those comments once again, and we'll just move on to the next component. Oops, we've just got one left there, and move on to the next component. So we've effectively published the data to the MQTT server using the last Node-RED screen. So the next bit is to subscribe to the topic, so we can grab that data and display that. Now, once again, the subscriber does not have to sit on the Raspberry Pi server, which I have just out of convenience. It can sit anywhere that supports a Node-RED system, and you can just subscribe to that by pointing the subscriber to the MQTT broker and the topic, and it's as simple as that. Before we move on to actually look at the Node-RED interface and how that Node-RED is put together for the output stage, let's just remind ourselves of what our final output looks like. So we have a collection of simple gauges that show, in this case, the battery, temperature, humidity and pressure. So just bear in mind that's what we're actually going to be seeing on our final interface. So this is the Node-RED system that I've designed. And once again, you know, there are 1,000 ways to skin a cat. This is just one way in which you can make this work. And again, it may not be the best way. So we're going to take a look at each or some of those little blocks in there just to see how they work. All right, let's take a look at the MQTT component to begin with. So that's this component here that I'm looking at now. So the display on the right of the screen here is showing the configuration for this particular component. So this is reading the data from the MQTT server. So effectively this block is subscribing to the topic. So you can see what I've got to do. I've got to set the local host as the IP address once again, and it's the same port number. This time, of course, I'm subscribing to rather than publishing to, and I have to say which topic I want to subscribe to. So that allows me to get the data from the MQTT server that's sitting there. Okay, so we've looked at that bit. Let's look at the next component. So what I'm going to do now is just to explain what the data is looking like now. Now what I've done here is just to do a screen capture from the message payload, and it's the message payload at this point here. So what we're doing is to take a look at the data coming out of this block here. The Node-RED system can pass data around in effect as JSON strings, which are absolutely fine, but they can look a little bit messy sometimes and not always the easiest to extract the data from. So there's some nice JSON processing blocks that allow me to extract the data and push it into a more useful format for me. So what I have here is system where it's showing me I have first of all an array with 5 elements, and here's the first element. It's another array with 2 elements in. The first one, well, both elements are a string, but the first one being bat, showing me it's the battery status, and the second string giving me the numeric value of the actual battery status itself. And the other array elements are showing the values that are stored for the other sensors. So we now have our data in a useful format, a more useful format, where we can start processing that and trying to display that data itself. So let's take a look at what we need to do to actually process that data. And what we need to take a look at is what's going on in this functional module. So let's take a look at some of the coding that's taking place in that functional module. It's really pretty straightforward. So we have some assignments going on where I'm just extracting the data and looking at the first example here where I'm just pushing the data from the message payload, and it's the numeric data, the battery status, into a variable battery or bat, sorry, and similarly for the temperature, humidity, pressure and carbon dioxide levels as well. So we've just passed that data across into local variables, and the next stage is just looking at how we generate a new message object, and this syntax allows us to push those values into that new object message that will obviously return for later on down the program. So we're doing that for each of the values: battery, temperature, humidity, pressure and carbon dioxide values. We can just ignore this little bit of commented out statement there that I'm just using for debugging and trialing some other things. And the final return statement, this is a clever bit of JavaScript. There's a missing square bracket off the end there that just didn't get captured in the screen capture, and it's just returning in effect an array of new messages. So each of those objects are returned as an array. Now the Node-RED functional module allows us to generate, in effect, an output for each of those messages coming out. So we're feeding those messages into subsequent units. So new message 1 feeds into this unit here. New message 2 feeds into this unit here, and likewise. So we're pushing that message across out to those further processing blocks, and those processing blocks are the blocks that actually do the display of the data itself. So let's just clear all that stuff off the screen. Just give me a moment. There it all goes. And what we'll do now is to take a look at what happens when we look inside what the battery display system is doing. So let's just bring that up. So this is the configuration of the battery display. Again, this is not fully configured. There's an awful lot more that we can do, but we need to do a few things. It's very, very flexible what you do here, but you need to specify the grouping, so all of the data is displayed on the same screen. You need to say something about the type of display that you're going to get. In this particular case, if you remember from looking at the first presentation, you'd remember that these are all displayed as gauges. We put a label in here. We've missed the value format out, and the units are percentage, and we give some ranges in there too. And it's possible to configure some color gradients as well to indicate what's good and what's not so good, and it's possible again to put a name tag in there. And that's about it, really. We've obviously done something very similar for temperature, humidity, pressure, and carbon dioxide output to generate those outputs. But it is really pretty straightforward indeed to generate some useful live output. And can I just ask you to refer to the previous slide set to have a look at that output? So that's just about concludes everything that I want to say from this Node-RED configuration perspective. And just to finish up, I'd like to say thank you very much for watching, and hopefully what's coming next in the series is a little bit of information about the coding that's gone on in the Libelium Lora module, and this is coding using its C-like language to actually sort of switch the Lora modules off, transmit the data and receive the data and so forth. So once again, thanks very much for watching.